environment, indoors, outdoors, and the ability to move cameras between different studios, different sets, different venues. And obviously, because of the speed of setup, the lightness, and the speed of the rig, we believe that, you know, I'd love to sell you a separate system for every studio you have, but, you know, understanding that's probably not palatable, we give you the flexibility to quickly and simply move cameras between different studios. Here is the hardware. Obviously, you know, Abel will show you this in person, but just really to highlight the key points there. Ncam Reality 2020, that is our core software. I've probably mentioned most of this. What we've really done there is the key points. Introduce the ability to track non-natural and also fiducial markers. We've done a lot of work to the core of the software to improve the stability and the robustness to changes in lighting, and of course LED walls, which is an emerging production technique these days. The one-size-fits-all approach. The previous software, as I mentioned, you would subscribe to 4 different tiers of software depending on what capabilities you needed. Confusing, complicated. We now have a single product which meets every requirement. I've mentioned the operational improvements to the wizard-based user interface, and of course, because that wizard-based interface is now web-based, that makes it a lot simpler for you to connect to and control the server, and also, if needed, for us to connect remotely and give assistance. On the hardware side of things, the two major components, the tracking bar and the server there. The camera bar itself, we realized that Intel, who had developed the RealSense platform, were doing tracking in a very similar way to our Mark I system. Obviously, Intel have you know, a great deal more resource, let's say, to plow into hardware development than we will ever have in our lifetime. So we've nearly now kind of developed the RealSense platform into something suitable for use in our industry. We've completely rewritten the back end. You know, we're using Intel's hardware, the firmware, the calibrations, the software is all our own. So the real kind of exciting thing about being on board with the Intel hardware roadmap is, you know, not only can we concentrate on computer vision and software engineering, which is where our strengths are, but also, of course, as Intel develop, if they introduce additional sensors and additional functionality, it's going to be pretty straightforward, we think, for us to, you know, to deliver those benefits to customers as well. On the server side of things, we're now giving you the ability to mount the server on the camera itself, so that all of that processing is local to the rig. That's something which was requested by clients operating in film who wanted to record the data for use later, who didn't need to access the data live. What we do have being released in the next couple of months is what we call the connection box, and that simply takes the data from the lens, from the sensor bar, converts it to Ethernet, so then the server can be located anywhere on that network. And finally, before I hand over to Abel for the more interesting stuff, this is the product offering. Again, just to kind of reiterate, a simple single product with Ncam Reality at the core and additional plugins.
You're off, Mike.
Sorry, guys, I'm not sure quite why I managed to go into mute then.
Now it's okay.
Sorry, yeah. Just explaining there the basics of the pricing. Reality hardware, 6,000. Reality core software, 12,000 US per year. And the plugins there on the right, AR Suite is where we've seen most activity recently. That's our suite of plugins for Unreal Engine, which Abel will demonstrate to you. So hopefully I wasn't on mute for too long then, guys. Handing over to Abel.
Thanks, Mike. Hopefully you guys should be able to see my screen now and hear me. If you just want to do what you did previously with Mike, if you just pin my screen, you should be able to see everything that we're going to go through. Okay, starting with this is our hardware. As Mike mentioned, we're now mounting our Mark II server onto the camera itself. All in all, it just helps with our kind of versatility and adaptability on site. The server and the camera bar together, they both now weigh less than our original Mark I camera bar. So we've kind of gone down in weight, but we've added the actual versatility to our rig. What I'll do, I'll run through some of the key components of the server itself, and then we'll move on to the camera bar. So starting from, we'll start from this side and work our way down. We've got our power input. So we're now able to mount and power our server directly from the camera itself. We have a wide range of power inputs for that. We've got we can use it off DTAP, 2-pin LEMO, 3-pin LEMO, as well as just using generic plug power supply. This just allows us to kind of be compatible with any camera on site. Full well that we can power it directly from the camera. Moving down, we've got our two kind of peripheral inputs. So we've got our HDMI and display ports. These are for obviously monitoring purposes. As Mike mentioned before, we now have an accessible web GUI. So preferably we would remote access into our server. Typically we'd use AnyDesk or a kind of a type VNC, which will work in the same way. So we wouldn't have to have a HDMI or display port should you not need to or want to. And then moving down, we've got our two USB ports. So simply just for adding USB devices. I've actually forgotten my Bluetooth keyboard, but I would preferably be using a Bluetooth keyboard and mouse today. And then moving down, we've got our ETH0 and ETH1 ports. So this is where we send our tracking data directly from the server to our render engine. So whether we're using VizRT or Unreal Engine, whatever render engine we're using, this is our main connection of sending our data from Ncam to our server. And then, as you see, we've got our two Wi-Fi antennas here. And as previously mentioned, that's for our remote access capabilities. If I just spin our rig around now, and we'll go into our kind of more computer and Ncam-based plugins. So we've got our video I/O. Video in is where we get our feed directly from the camera itself. Along and on this data line, we also this enables us to synchronize our tracking data with the video feed that we're getting in. If the camera itself is unable to provide time code, we can loop it in through Ncam and then spit it back out with embedded time code. So it's it's another handy asset that we've got for our Mark II server. We're always able to sync our data to any camera feed. Moving down, we've got our two 7-pin LEMO ports here. One is labeled UART and the other is our RS232 protocol. Both of these are what we use for our lens encoding data. So at the moment on this rig here, we've got our Mark II smart encoder. So this is currently connected directly to our lens server. It's taking in all the focus and zoom data and pushing it straight through into Ncam. And then using our own kind of calibration system that we've got bespoke to Ncam, we're able to create our own specific distortion map, which allows us to then focus and zoom in on AR objects, assets, virtual sets, as if they were in real life. So the lens behaves in a way that we would expect it to. And then our other one is our RS232. If one of these ports is being used for lens encoding, the other one can double up as a power output. So at the moment, we're using our smart encoder in our UART port, but our secondary RS232 is currently powering our IR emitter, which I'll get into shortly. And then our last input is our USB-C lockable Neutrik connector. This connects our camera bar directly to our server. And obviously, being a lockable device, we can add that additional confidence that we're not going to, accidentally be unplugged during, any, wild camera moves, or cameraman himself's not going to accidentally pull it out. And that's an addition that we've, upgraded from our Mark I, where, clients were kind of wanting to be reassured that main connection is lockable. Moving on to the camera bar itself. I'll just spin this around. So similar to our Mark, just tying up. Similar to our Mark 1 camera bar, we've got our two grey stereoscopic lenses either side of our IR emitter. They have a similar wide angle range as our Mark 1 system, so we're not losing we're not losing any vision from moving up into our Mark 2 system. It carries the same capabilities. In the center here, we've got our IR camera. This currently isn't in use, but it will be utilized in the future to help further improve our capabilities of tracking IR markers in dark environments. Although we can currently do that, and that's something that we are leaning on at the moment. This will just boost those capabilities for us in the future. And then on the far left, we've just got a color RGB 1080p camera, and we can use this for additional calibrations and lineups within Ncam itself. As I mentioned previously, this is our IR emitter, currently powered directly off our server, off the spare 7-pin LEMO port. This simply kind of just sprays an IR pattern into the environment, and then once that pattern connect with IR markers or reflective circular markers, our system is able to pick those up and use those as tracking points. In terms of how we're mounted, we're obviously now going with a nice easy option of using magic arms, which are inexpensive and very easy to get hold of. No longer are we having to lean on having rod plates where our Mark 1 would sit. Obviously having a whole wide range of different size rod plates often cause a lot of issues on site when if you haven't got the right locking plate or rod plate size, it could be an issue. And then just a quick comparison of our camera bar to our previous Mark 1. Obviously huge size difference and weight saving difference as well. Obviously having the Mark 1 camera bar hanging off the bottom of a camera, counterbalance wise caused a lot of issues. And also in terms of our actual lenses, they're now protected by a sheet of glass. So the Mark 1 often found it was very easy to get knocked, and cracking the lenses themselves. Great, if I now move on to our actual software, and we can get into the fun part. Okay, so this is our this is the Ncam software. This is our kind of homepage of what you'd expect to see on any on our servers. In terms of, as Mike mentioned previously before, our tracking capabilities. So this is our these are two stereoscopic cameras I talked through earlier. If what I'll do, I'll start from scratch and just delete our point cloud. So at the moment, we're currently not tracking anything. This is where we would see our tracked points. Obviously, Ncam, we've got a range of different ways we can track our environment. Our kind of baseline of our tracking core. And I go back to our tracking view. Now you can see that Ncam is looking for points of contrast. Typically Ncam kind of loves corners and edges where two objects are meeting. You can see it's picked up some points off the wall where our kind of green tape is on our green wall. So this is kind of where we would select a 0 point to say. Just to give you a quick talk through of what we're actually tracking. You'll see that some points are blue and purple. So the blue and purple points are what we call zonal track points. So Ncam will pick out larger parts of an environment, knowing it would measure kind of like a meter distance, and it would keep those track points. So if we're kind of doing like a fast pan or quick tilt, and some of the smaller, finer detailed points, which are the green and yellow ones, if it loses those natural markers, maybe due to lighting, or the camera moving at high speed, it will automatically change between the tracking cores, which allows us to keep a consistent level of tracking. So as it's constantly using a fusion of data, it's never kind of switching one off and turning the other one on. It's, you know, they're always both on at the same time, but it's just switching between the two in a fluid manner. So, you know, we're not sacrificing our tracking core at all. And in you know, your output and your composite is always a steady, clean track. As Mike mentioned before, we've also got our IR capabilities. I will go into those a bit later and show you those too. So what we want to do now is we want to set a 0 point in our environment, and the 0 point is kind of the mesh between, you know, the real world and our virtual world, which is where, you know, we line up our maybe our virtual set or our, you know, our AR object, and obviously is you know, huge importance to tracking. You know, we need a solid 0 point to have solid tracking. There are different methods of how we'd select a 0 point. We could either select a 0 point off of one of the natural markers we've picked. So I could pick a 0 point on the wall, and I've set our 0 point on the wall up there using one of our natural markers. But another method that we've got is a newer method that we're kind of leaning towards, just in terms of its ease of use. If I just move our camera just down a bit slightly. Now, if I head over to our tracking view, you'll see that I've got a marker placed on the floor. This is what we call a fiducial marker. Or to me, is basically a QR code. And once Ncam, or, you know, our camera bar sees this fiducial marker, if we it takes one button to basically set a 0 point, and then all of our axes are lined up as well using this simple marker. So if I head over to our image model where we select our 0 point, if I just refresh our point here, and then as soon as I hit F10, our 0 point automatically is locked onto our fiducial marker. And then if I turn off our keyer, you'll see that our 0 point is sunk onto that fiducial marker, and we're able to do that consistently each and every time. So if we, for example, if you were on set, you could, you know, we kind of print these on 3D foam boards, and we can place the mark on the floor, point the camera bar at it, hit one button, and then your 0 point is, you know, where it was the day before, and there's no need to kind of realign your environment. You don't have to worry about your studio setting changing too much. As long as your 0 point and your fiducial marker is in the same place you left it, or you've marked, you're good to go. Just on the right hand side, this is kind of the back end of Ncam and the stuff that kind of goes into maintaining its tracking. Generally, once we've kind of set up the system and you know, you kind of set up in your studio environment or wherever you're going to be shooting, these settings tend not to change too much. They only tend to change if you're changing either your lens or your actual camera body as well. So and then when you are changing your lens, we kind of keep a database of the lenses and the camera models that we've got. And then you kind of select, you know, based on what you're going to be using, what you're going to be shooting on, you select your lens, and then you're good to go again. And then these settings will change in alignment with you changing your lens. So now we've got our 0 point set. How do we use this? And where do we go from there? So if I tab over to our Unreal Engine, if I just stop our game here. So this is our, you know, our virtual world that we've got, and our virtual studio. This was created by Mosaica Creative. It's kind of like a cross, but, you know, we've got a lot of different sections of the studio we can pick. We've got our video reels playing in the background. Once we start the actual composite, these will begin to play and you'll be able to see those. For this demo, I've selected, kind of scouted this corner of our studio over here. If I go into our actual main menu, so this is our another part of Ncam is our virtual. This is our virtual camera within our virtual studio. This is part of our plugin that's available. We do have a free version which is available on the Unreal website. free to download. So this is all part of that package. In terms of what we can do, so I've set my 0 point, and now the camera is kind of snapped back to where I originally had it pointed when I first kind of set up that 0 point. And now you'll see I'm just off cam now, but as I move the camera around in real life, our virtual camera moves around in the same format. This is, so handy when we're trying to scout scenes and, scout parts of your studio that you want to set up. You don't have to kind of move around within Unreal. You can actually scout using the actual virtual camera itself. So now we're set. We've kind of got our position on our green screen. What I want to do is I want to show you the what data we're actually sending from Ncam into our Unreal Engine. So if I go to our media profile, and then we'll go to our timecode sync. If I'll stop and start again, just refresh. So these are the kind of 4 packets of data that we've selected to send to Ncam. So this is our tracking data at the top here. Not an actual image, but we're getting our time code correctly, so we know it's synced up. Below is our film image. So this is our obviously our SDI feed directly from the camera into our render engine. And then this kind of green to red is our distortion map. So this is our lens calibration that we've previously done, and this contains all of the data that we've calibrated via Ncam. Each lens that we calibrate would usually take about an hour and a half, an hour maybe. And then for prime lenses, usually about half an hour. Obviously, depending on your lens, different lenses have different distortions. So we tend to kind of calibrate a lens on site or at Ncam office here at Ncam. But that's usually kind of a one-off step. So once a lens has been calibrated, it's done. You've saved that to your database. You don't have to kind of go back to that file ever again. And then depending on how many lenses you want to use throughout your shoot, you need to calibrate each lens. But the process is quite simple, and I'll show you a bit of that after. And then below is our, this is our key. If I just go back to Ncam briefly. And then I'll just enable our key. And then, yeah, there's our key. So we're getting our key for our green screen. Obviously, Ncam's got its own key, but you could use a key from any other output should you need to. So now we're getting our track data through to our Unreal Engine. We're now able to play our game instead. So if I go to our full screen, I'll just head off cam just so you can see how we're lined up. So as you can see, yeah, we've got our our green screen wall that we've in our Soho office, but we're kind of limited by the space of it, as you get in many studios, to be honest. We've got a lot of kind of visual noise that we want to get rid of, but we're able to do that using our Ncam plugin. So we've lined up our walls as expected. Obviously, we've set our Fiducial, and I've previously lined up the room to match our walls. But now we kind of want to expand our our environment and improve our production value. So if we head across, if I stop the game now, and then if I just go over to our camera, select our camera. Obviously, there's an entire kind of pipeline of different assets that we can alter and change within our plugin. But just one I wanted to show you guys through for this demo is our obviously ability to mask. So if we enable our masking protocol here, what this does, it basically tells Ncam to ignore anything that's not green screen and just show the composite of our virtual asset. So if I now play our virtual game, go to full screen. Again, I'll just move off camera. But now if I kind of pan and tilt our camera 360, you'll see that we've kind of got our whole virtual set that I previously showed you, but we're now able to kind of move around it freely, as if we had the whole studio to play with. As I said before, because we're getting our focus and zoom data through our lens encoder, obviously we're able to now pull focus and zoom in on different parts of our studio. So if I just rack that back to visible, so yeah, it's kind of like a nice way just to expand what you're able to show off and use. Obviously, dependent on your green screen size and and your environment, there's no reason why you couldn't have your host or presenter moving around different parts of your environment. So in terms of our virtual studio, that's kind of the main kind of virtual tour done. If I just quickly flip back to our Ncam page, I would like to show you how we actually calibrate the lenses quickly, very briefly. So just give me 2 seconds. So let's enable our keyer here. So in terms of our of what Ncam is kind of using in terms of data, this is kind of a 3D visual guide of what Ncam sees. So this top camera here, or this top bar, that's the Ncam camera bar itself, and then this one below is the actual main camera. And the distance between the two is worked out by a calibration that we do. We basically show both cameras the same chart. If I go to our camera here, yeah, we basically show both cameras a chart like this, and then once we kind of press start, we kind of get a rainbow effect on that chart, and then we just take 10 screenshots of this chart here. And then that kind of works out the relationship between the two cameras. So Ncam is able to work out where it sees a cube, and then the SDI camera also. And then once that calibration has been done, as long as the camera bar doesn't change its orientation, your relationship is solid. The only time you'll have to do that calibration again is if you tilted your camera bar up 90 degrees maybe, due to if you've got LED walls straight ahead, you don't want to be tracking off those. You just have to kind of redo that small calibration again. In terms of the points here, so this is, if I just untick our use points, so these are all the points that Ncam is taking in at the moment and is using. And then if I kind of move the camera around the room, you'll see that it's constantly building a point cloud and picking up new points within the environment. And obviously any of these points can be used to further improve your actual tracking, or just to kind of set as a 0 point. If I spent 10 minutes panning and tilting around the room, you'd see the shape of where the kind of door is and where the kind of ceilings meet. In terms of our ability to track IR markers, if I just tilt our camera up at the ceiling where our markers are, I'll turn off our lights as well. So now I've got the lights completely off, and you'll see that our IR markers here are being picked up by our IR emitter that's emitting light on, and we stuck our reflective markers up, and then within the 3D view itself, the IR markers are represented as the kind of red crosses. So we're kind of able to differentiate between the two. But there's no reason why we couldn't use IR markers independently on their own. But depending on your studio environment and what you want to use, you're able to flick between. So we just kind of got an easy menu. So we have natural markers, which we can use, and then as well as circular features as well, and Fiducial. So we can turn on whichever ones we kind of want to use. That's the kind of end of the demo, but if you've got any more questions for myself or Mike, feel free to ask.
Yeah, thanks very much, Abel. Really interesting. Manish, I believe you have a question. You can type that on the text or speak, no problem.
Hi guys, I have a simple question. How is the workability or functionality different when we use LED walls instead of a chroma screen?
Yeah, great question. Do you want to explain that, Abel?
Yeah, sure. So was that in terms of using LED walls or LED screens?
Yeah,
Yeah, LED screens.
Yes, yeah, a lot of customers are now using or wanting to use LED walls, which is, you know, the way technology is going. In terms of our capabilities, what we would tend to do is obviously point our camera bar away from the LED wall itself. So typically we point it, 90 degrees up at the ceiling, or in an area where we're not surrounded by an LED wall. So if the LED was straight ahead of us with a ceiling, we could point the camera backwards. It doesn't have to be facing the same way as a camera at all. And then we just have to kind of do a little small calibration for our camera bar to know, its relationship to the main camera. And then we just track as normal, just as long as we're not tracking directly off the LED wall. I mean, it can track off the LED wall, but in terms of what is likely to be shown on the LED wall, be it like a moving image or film. So we tend to, track anywhere where we're not facing the wall.
Yeah, but just to expand on that a little bit, there's, like you say, there's LED as a challenge because obviously the image in the LED is moving. We track static points. It really depends how much LED you have. I mean, what Abel's described there is, if you don't have an LED ceiling, that's great. Point up, track off the lighting rig. If you do have an LED ceiling, consider, is your camera actually going inside the LED volume or not? Quite often the camera is still outside, so that's fine. We do have a few people these days who want to work in full 360-degree LED with LED floors, LED ceilings, and obviously that's the toughest challenge. I've seen that done in a couple of ways. Certain manufacturers of the LED panels are now also selling, they're integrating infrared reflective markers within the LED. So they basically will supply small sheets of infrared reflective stickers, which are actually black in color, but they have obviously a very fine grid of holes pierced within them. So they locate those over the top of the LED. So there's an an infrared reflector there, but the LED still shines through. That's one technique, and the LED suppliers will make those. The other way is an interesting technique, which what you basically do is your CG scene that you're replaying in your video wall, you superimpose a static layer over the top of that of white markers, blobs, crosses, whatever you want. But you configure Unreal so that those markers are switched off within the camera frustum. So where the camera can see the screen, there's no markers. Where the camera can't see the screen, over the top of the video, you have some markers for us to track, because obviously our field of view is much wider than the film camera. So a variety of techniques.
Thanks for this elaboration, Mike. It was really helpful. I just have one more additional question on this. Was this same process or workflow used while creating the Mandalorian, or did you guys work with Mandalorian team by any chance?
I believe the Mandalorian was done with OptiTrack, the OptiTrack system. One of the key advantages that we have over OptiTrack is the speed and simplicity of setup. OptiTrack is you build it in a volume, you don't move it because it takes a long time, and also you probably need to add a few zeros to your budget if you want to use that system.
Got it. Thank you so much.
But the technique is exactly the same. I believe Raman, do you have a question?
Oh, yes. Hi there, guys. So I wanted to know, I've heard that Ncam also carries depth information where we can throw a point cloud in Nuke. Is that true?
Ooh, that's a question for Abel.
So our usability of our point cloud, we have the ability to save our point cloud. So all of the data that our camera bar takes in and all of the points saved within the point cloud can be saved as a physical file.
Yes. So I'm not talking about the point cloud, what it is showing right now, but I've heard that the whole scene, you know, like how Lightro camera was working, you know, which is having depth information, because of which you can add a chroma or a distance behind any information or behind any character. Is that possible with Ncam as well? Because I've heard that's happening.
Yeah, I think it's something that we're definitely like far in the process of doing. The details of how far along it is, I'll have to ask our R&D team.
Okay. Because my another question was, if that is happening, then why we need green screen? Because if you have such a rich depth information on every shoot, I don't mind if it's the recording data is not working live, but in the after when you have shot the data, you can get whole scene in Z depth information in Z.
I've got some more information on that one. You'll probably see, if you search the web and you search YouTube, for example, you'll see a demonstration of what we call real depth. So real depth was designed to allow actors to interact with virtual objects. So you'll see a demonstration of a guy walking around in a computer generated forest in front of the trees, behind the trees. So that was a proof of concept that we did for Tencent over in China a few years back.
Okay.
It was never developed into a full product, and what you see there is the reason it wasn't used is it still had to be in front of a chroma key because the depth information wasn't accurate enough. We do definitely still have the plans to explore generating a depth map in the future. As Abel mentioned, we'll have to find an update on that. But we know that I think Abel showed you on the sensor bar itself, the blue lens in the center is actually an infrared depth camera. So we know that capability is within the product, but the reason we're not using that today is if you look at the specification sheet for the Intel product that we're based on, it only has a range of a few feet.
Okay.
It's very accurate. It's very similar to a face camera on your iPhone. So the depth resolution is very good, but the range is very short. But that's something we have in the plan for the future, because we know that the holy grail would be to be able to shoot without a green screen at all.
Yes. Okay.
So not today, but maybe.
So right now, whatever we're shooting, we have to go through getting the right green screens, because I was still able to see some lag when you were shooting right now, when you were showing the demo. I can see there were these glitches coming around. So I believe that is happening because because we are not recording, and in the recording that won't happen. Is that so?
That should be the case. Yeah, I noticed that a couple of times on your demo, Abel. It did look like the key was delayed slightly.
Oh, really? Okay. Maybe I've not set it up properly in our Unreal Engine, but usually it's super smooth.
But that's still okay for me. I don't expect it to be because this is still evolving. But the whole idea I was going through this session was, I've heard that it gives nice depth information, but now I'm clear. So if I'm using Ncam, I have to make sure my green screen is right. It's just that my tracking work has been resolved. If I use this this technology for any shoot, the tracking thing has been resolved. Is that so, right?
That's correct. Yeah.
Okay. Cool. Because I'm planning to use Ncam, but not in conjunction with Unreal for right now, because that would be too much of a research work on our heads for a new project. But definitely, I'm using Ncam for the post work.
Okay. Yeah, that makes sense.
So how better it can help me? When I think about getting chroma rid of, if I'm not using live, can I still use Ncam with my solo camera and the traditional technique and what better it can give me on post. Can you elaborate on that?
That's probably one for you, Abel. That's more technical than me.
So yeah, so you're looking to use obviously Ncam in post, but in terms of like a render engine, are you obviously you're not going to be using Unreal? Do you have one in mind that you want to use?
No, not Unreal, no, nothing. After the shoot is done, it's just that the guys who the shots we are struggling for tracking and chroma removal. I just wanted to know in Nuke what it can help, because I was just looking at the UI of Ncam. It just looks like Nuke, so I thought like it is more compatible with Nuke. Is that so?
Okay, we're definitely compatible with Nuke. In terms of our data, obviously we're able to record the tracking data itself, so you can import Ncam's tracking data into your render engine,
Okay.
and use it in there.
Okay, but not in Nuke.
So today, the data export we give you is an FBX file. So we give you the point cloud as an FBX file.
Okay.
We have a new piece of software called Export, which is going to be released. It's in beta. It's coming out in the next few months.
Okay.
And that will give you the ability to support Alembic and USD files. So
Okay.
obviously, I believe Nuke will work with Alembic. But the other thing that software will do is it's designed to make it much easier and more straightforward to integrate that data. And we have some kind of, like I say, the software is not released yet, but we have some kind of provisional background information which we can send across, no problem.
Can you repeat the name of the software again? Sorry.
Yep, it's simply called Export.
Can you just spell it out?
Yep, XPORT.
ORT. R for rat, T for tortoise.
I'll type it into the chat box.
Sure. That will help.
There you go.
Okay, export. Okay, sure. Cool. Thanks.
No problem. Any more questions from anyone? No. Well, obviously, as we say, for those guys of you out in India, any further questions, you can get in touch with the team at ARC. Anyone who's based in Europe, feel free to reach out to myself. And any more information, any follow-up questions you have, we can certainly talk more. Hey, Ricardo, did you have a question?
Yes, thanks. I haven't understood if the lens information like zoom and focus, how do you get them? And if we need a separate lens encoder sending the data or not? Yeah,
so there's many ways of doing that depending on the lens you have. The lens that Abel had there has its own lens servo grip on the side, obviously. So we support the kind of the common ones from Canon and Fuji that have their own encoders. You tell us whether you have Canon or Fuji, we give you the correct interface. If you're using Stiny lenses, there's a few ways there. If you're using an external follow focus, for example, Preston or any of the others, let me think, Preston, C-Motion, for example. Again, you just tell us which you use, we supply the correct cables. If you have any of the newer, let's call them smart lenses that support LDS, XD, /I protocol, again, tell us which lenses, we provide those. We also have another method, which is for some of our customers these days are using very cheap cameras, very cheap lenses. So if we say you need to spend 10,000 on Preston, that doesn't work. We actually manufacture our own set of passive external encoders, which are around $500. And they just mount to the outside of any lens. As long as you've got rotating focus and zoom barrels, we just read the values from them.
Yeah. Okay.
No problem.
Thanks.
Okay. So we've got a question on text. I believe it's real-time tracking, just like you track and export the camera tracking from software like Synthesize. Similarly, export could be used in Nuke. Yeah, exactly. Correct.
Yeah.
Are there any more questions, guys? No. Okay, well, I hope everybody found that useful, interesting, and sorry with a few glitches, and sorry I managed to press my mute button for a few minutes. Final question. Do you want to answer that question, Abel, about anamorphic? Because I hate lenses like that.
Yeah, well, in terms of anamorphic lenses, we usually, you know, like I said, a zoom lens calibration will normally take an hour and a half, an hour, and an anamorphic we tend to double the time it takes, so maybe 2.5 hours for an anamorphic. Not the same. We don't use the same. Well, in terms of calibrating a lens, we basically move through the focus and zoom points on the barrel. I'll just show you actually in terms of what that looks like. So that's kind of a 3D view of our map. If I just move through the zoom, you see that kind of moves with our graph. And then once we kind of calibrate 10 points on our lens, and we kind of take screenshots of this across the entire frame. And it's just a similar process that we use for the anamorphic. We just have a larger chart, and we kind of get the whole chart in frame with that anamorphic, and then continue the process. But yeah, we're compatible with calibrating any lens, including anamorphics.
Great. All right, guys. Then, unfortunately, time has expired. But we will forward you a link over to the recording, which you're welcome to forward on, and look forward to speaking with you all again soon, and possibly even seeing some of you in person one day. Yeah. Talk soon. Thank you very much, Abel. Well done.
Thanks, guys.
Cheers, all.
Thank you.
Bye.
Thank you.
Thank you.